We're now going to take a look at what happens when we use strings as parameters. Remember that when we have a reference variable, we use the new operator in order to allocate memory and then store the data for that object. For strings, this is also true, but we can also assign a new string to the variable and not just use the new operator. So this would end up creating a completely different string from what was originally stored in our string variable. So for example, let's say I have str be initially hello. And let's say I want to assign the string hi to it by just saying str equals hi. Now that means that str now stores a brand new memory address instead of just the string itself. Now let's suppose we pass a string variable as a parameter to a method. And then within this method, let's say we assign a new string to that parameter. Since we're dealing with reference variables, you'll probably think that we change what was stored in the argument, just like other reference variables. So I changed the memory address, so it means I changed the memory address of my argument, right? Because we're dealing with the changing objects. But this isn't true. This is because a new string is stored in the parameter, just like we were just saying earlier that we're creating a completely different string. So this means a different memory address is being stored in the parameter rather than what is stored in the argument. So remember, with reference variables, if I pass a reference variable, I'm passing the memory address. So when I change the object, that object has both the parameter and the argument pointing to that same object. So if I change the object, I see that change in both the parameter and the argument. With strings, if I make a change to my string variable, that's going to create a completely separate object. So now my argument and my string are looking at two completely different addresses. So what I changed in my parameter does not happen to my argument because my argument is still pointing to the original string. Now let's use a similar example that we did earlier, but now apply it to the strings. So we're going to create a string variable. We're going to pass it as a parameter to a method. We're going to change it, and then we're going to come back and let's see what happens. So we're going to do public class, then we'll call this params, just so it's not, just so we don't confuse it with what we had before. So we'll do public static void main. So put all that in here. And then let's create a string variable. So we'll do string str. We'll set it to hello. And then we'll print it. Print str plus a blank. And then we'll do formal param str. And then it's just .out.print. There we go. So let's do our method again. We'll redefine it. Static void formal param string, we'll say p str, just so it's a little different from our argument. And then we'll print. Okay, so now let's change our string to be, we'll say sunny day. There we go. And then system.out print pstr. Oops, there we go. All right, we'll save it. So this does the exact same thing from our earlier example. It's just now we're dealing with strings instead of integers. So let's see what happens. We'll compile. Everything is good. Let's run it. We get hello, hello, sunny day, and hello. So just like we were saying before, with the string, what happens here here should not be really anything surprising. So we store hello, we print it, and then we send hello over here. But remember, this is storing the address of the string containing, or the address of the object that contains the string hello. So we print that here, but this is a different string. It's a different object. So the address of this object is now going to get stored in pstring. That's what I'm going to call it that. So when we print this, we're now printing the string at the new address, which is fine. So that's why we print sunny day here. But when we come back, this string still has the address of the original string. So we're going to print that string. So that's why we print hello here instead of sunny day. So if we want to pass strings as parameters, and then we wanted to make changes to them, if we want to change it so that it changes the arguments, we can use the string buffer class. This is actually very similar to the string class. The only difference is that strings that are assigned to string buffer can be changed. We can take the variables in there and actually change the values. Now to do this, we have to use very specific methods. The append method lets us append a string to an existing string, and the delete method deletes all the characters of a string. And it's important to note that we cannot use the assignment operator in this class. We have to use the new operator to initially allocate memory space and initialize our string, but we cannot use the assignment operator, but we can use append and delete to add characters and remove characters. Here's the exact same code from before with our string. Let's go ahead and make some changes to it so that we use the string buffer class instead of just normal strings. And what we'll see here is that when we make changes in our method, those changes also apply when we get back to our main. So I think we just need to change one line in our main method. So we need to do string buffer, and we'll call it str, and we'll do new string buffer, and then we'll put in hello. Okay, that's the only change we need to do for our main. Everything else is fine, but now we need to make several changes in our other method. So we need to change string to string buffer. This part is the same, but now we need to change how we reassign our p string, because it's no longer just saying it equal to something. We have to delete all the characters, and then we have to append a new string. So we need to do pstr delete, and we need two different things in here. We need the index of where we start, so we're going to start at the very beginning, and then we need to put the ending part, and it's exclusive. So it works just like substring in that case. So 0, 1, 2, 3, 4. So we need to go 5. So that means they'll delete all the characters up to but not including number 5. And then we need to append the string. So pstr.append. So then we're going to do sunny day. So we'll save that. So what this should do is in here, my string at this point is hello. This is going to remove all the characters, and then it's going to add sunny day to the buffer. We'll print sunny day here. And then when we come back to main, the address has not changed. It's just the contents within that object have changed. So when I print this, it's still going to look at the same object. It's just now what's in there is different. So it should print sunny day. So let's compile to make sure everything works. No compile errors. And let's go ahead and run it. So we get hello here, and then we call our method. So in here we get hello, makes sense. We deleted hello, we added sunny day. We print this, which is sunny day. And then when we come back here, notice that, yes, in fact, we did print sunny day. So this is just a way we can show that we can make changes to our string in our methods and actually make those changes apply to main. We'll conclude our lecture by looking at the primitive type wrapper classes. Now, we already know that if the parameter and an argument are primitive data types, if I change the parameter, it doesn't change the argument. That's a problem, because what if I want to make changes to integers and doubles and send them back to the arguments? There has to be some way to pass primitive data types back. Well, fortunately, for each primitive data type, Java does have a class so that the values can be wrapped in objects. So this lets us create reference variables of primitive data types. And you might be thinking, how do we do that? Well, we've already seen one class that does that. Actually, we've seen 3 classes that do that. So if you remember, for example, we have the integer class, and we can use this to wrap integer values into objects. We can do the same thing with doubles. We can have a double class and use it to wrap double values into the objects. And then so that means we take the reference variables associated with these classes and pass them to the parameters. But we're going to get a problem that's very similar to strings, in that there are no methods in these classes that let us change the values of these objects. So just like with strings, I can pass them, but I can't make any changes. So what we're going to have to do is end up creating our own classes if we want to actually pass these values. Now, we haven't gone over anything enough in order to figure out how to create our own classes, So we'll kind of go over this in more detail later on after we discuss how to create our own classes. So by the way, we're going to learn how to create our own classes later on.